All right, so I'm live here with 52 weeks of Swift, and today I'm going to be covering functions in Swift, which is always my favorite topic, functions, because they're the unit of work that really allows you to just get things done without needing to mess around too much with, you know, doing a lot of object-oriented programming and logistics of code. So let's just get right into it. I'm going to share my screen and get started. So I will share my entire monitor here. Okay. All right. So I'm going to start with this section of the Swift official guide here and just, go through it really quick and say, functions are self-contained chunks of code that perform a task. I call them units of work. And every function in Swift has a type, which is kind of nice. So you can actually return a type, which is unique to languages that have typing. And we should probably start with how do you actually define a function and then call it. And so this is a good example right here. Is you use the word func, right, for func, and then we define that it takes a variable called person, which is a string, and then we declare a immutable variable, which is let, and then we return back that. So kind of a hello world type function here. Let's go ahead and build this out. So in the right here, I'm going to put this into my editor and run this. Let's go ahead and take a look. How would I actually call this thing? Well, fortunately, pretty easy, right? We know that it takes a string. So I can just say, in this case, greet, and I could even print it if I wanted to, say print greet. And then I can say, let's do a string. We'll say Bob. There we go. And if I go through here and I return this, we see that it takes a person. So let's go ahead and do that. We'll say person, string Bob, go through and run this thing. So I've got all kinds of problems here. I guess, having issues with my syntax. So let's go ahead and just throw in their syntax here and just make it a little bit easier. We'll use Anna. There we go. So basically what I do is I call that function, which is greet. I pass in the person variable, and I put in the definition of it right here. So basically I'm able to use this key value based approach to call it. And I could obviously call other variables as well. So, if we look at the documentation here, it says that there's a separator that can be wrapped into the print statement. And this allows you to print the string and see its return value. So in this particular example, it says to make the body of a function shorter, you can combine the message creation and the return into one line, which is, again, very similar to Python, which I think can be helpful. A lot of times you just want to do something really quick and you want it to be a shorter piece of code. There we go. Look, I don't even have to do anything. I can just say person right here. And if I run this and I define it, it says greet again. And we need to take the right function name. And let's just clean this out. And we say greet again. And this is going to return back hello again, Anna. And so the difference here is that I just do string formatting all in one line, which is kind of nice because basically there is no logic other than the return statement. Now, what else can we do? We can do function parameters and return values. So you can build functions without parameters. That's like a classic function, is you just essentially return some value. So it's essentially like a container, right? It's holding something for you. It doesn't take any input. And if we go through here and we run this, we can see it just essentially is almost like a variable, right? It just says return hello world. We run this. And if I want to run this thing, I could just say print, and I could just say hello world, and just call that function, right? It just basically returns back this string. You can also do multiple parameters. This is also pretty classic in many languages. right? Where you want to do different things based on what's passed into the function. And in this particular function, they have a string and they also have a Boolean here, a bool. And this is going to basically allow us to also return back a string. So this is kind of nice, is that you can actually say in this particular function that not only am I accepting a string and accepting a Boolean, but after doing all my work, I'm going to return back a string value in my return statement. So let's go through here and let's grab that. And in Python, you would actually do a different thing, which is you could actually go through and you would basically put this inside the documentation, which is very different, right, than having to do it in person. Now, don't know why that's giving me errors there. It says, what does it say here? Cannot find greet again in scope. So I need to pull greet again back here. So let's go ahead and throw this in. That's what happens when you cut and paste code, is you actually need to understand what you're cutting and pasting. That's always the trick. So here we go. And now it found greet again. It's also needing greet. So we need to find that one. Here we go. Here's our greet. So basically I need to pull all this code back here. And this is actually kind of a good example. As we see, we have multiple functions and they're all working together, right? You have a function and then a second function, and then you have a third function. The third function goes through here. Now this one, I don't know. It's called greet. So we may not actually need that. Return back. Well, let's see what happens here. I don't know why we would need this. We probably don't need this. We can just go through here, say greet, and then say, yeah, we don't need that second one. Now this one, it says that missing argument for parameter already greeted in call. So how would we call this thing? Let's scroll down here and let's just say this. Let's see if this one actually works. There you go. And it looks like we are, yeah, having that same problem here, which is definitely kind of weird. Well, I'll come back to that one later. Not sure why it's acting weird, but basically the gist is you can have things that have multiple inputs. So the next one here, which is a greet here, and we can just say person. So in this case, they're showing that a function can just print, which in some cases is cleaner, right? Because now I don't have to actually call print on that. It's just essentially does some work, and the work doesn't return anything because it's possible that I don't want to capture the output and put that into somewhere else. The return value of a function can be ignored as well, which is kind of neat. So in this case, this is a syntax that says, look, just throw this away, right? That's what that underscore does. We can just say we don't care about it. So we'll go through here, we'll grab this thing and just throw it away, which is kind of neat. There we go. Hello world, hello world. Now, what about a function with a multiple returns? Now, this is a scenario I think that can be useful. It does make your code more complex, but in a situation like this, depending on what it is you're doing, you may want to return something that has multiple values. And so in this particular example, what we do is we have two different arrays. We have a current min and a current max, and they're both values are actually returned as a tuple. So this is also very similar to the way Python does multiple returns. And then if we go through here and we run this, I'm assuming you're going to unpack this later. And what we do is we say min max, we say let bounds equal this, and then we will be able to actually, which is pretty cool. So it says because the tuple's member values are named as part of the function's return type, they can be accessed with the dot syntax. Now that is actually pretty cool. So if we go back here and we see the return type, which is right here, you can see that it's going to return back a min and a max. And so this is definitely pretty fancy, is that I then create a variable to call this thing back. And I say, look, here's my variable bounds. I call the function I just defined, put an array inside of it, and then I can do a print statement that takes this new variable that I created, which is the return value of the function, and it automatically has a min and a max associated with it. So pretty cool to be able to do that. I definitely learned something new today. What else can we do with functions in Swift? Optional tuple return types. So you can say if the tuple to be returned has the potential to have no value, you can do an optional value. Well, okay, that's kind of interesting. So basically, what we do is we have, in this particular scenario, we also say min max, it will be the return, but then we say if array is empty, then return nil. So if somebody passes in an empty array, then it will return back one value. Otherwise, it will return back this other value, which is defensive programming, which is potentially useful. And we go through here, and then we try it out. And if we say, in this case, you could pass this in, and we can call it again. And I guess I don't know if that's got some kind of formatting issue or what, but let's try that. Well, I won't try to fix it. Okay, so functions with an implicit return. If the entire body of the function is a simple expression, the function implicitly returns that expression. For example, both functions below have the same behavior. So we have a function. This one basically has no return value other than, that's pretty interesting. So we don't even need to say a return statement. It'll implicitly return because we did say that. That's interesting. And so in this case, we do have a return. So that is kind of nice. So if the entire body of the function is a single expression, the function implicitly returns that expression. That's definitely a little bit tricky, but interesting. I guess we could just run all that and just take a look at it. But I guess that's similar to languages like R, where you can have a return there, where it's the last line. Here we go. We have function argument labels and parameter names. And so this is both an argument label and a parameter name. So the argument label is used when calling the function. And in particular, by default, the parameters use their parameter name as their argument label. So function, some function, first parameter. Interesting. Don't really know what they mean here, but let's run it and play around with it. Some function, first parameter, and the function body, first parameter, and second parameter refer to the argument values. Yeah, I don't off the top of my head see why you would use this, but it looks interesting. Here's a great variation specifying argument labels from hometown, return. Yeah, I'll have to look into that later. I'm not sure about the labels here. That looks a little fancy for me. There's also a variadic parameter accepts 0 or more values of a specified type. You can use this to specify the parameter that can be passed in. And so in this case, this calculates the arithmetic mean or the average for a list of numbers of any length. Interesting. That's also kind of a cool little technique. And then we also have in-out parameters. So function parameters are constants by default. You can change the values of function parameters from within the body of a function, but that will make a compile time error. So how would we fix this? Here's an example of a function called swap2ints, which has two in-out parameters called a and b. And so this simply swaps the value of b into a and the value of a into b. Okay. and we say let temporary a. Not sure also why you would do this, but looks interesting. I mean, I guess I can run it and just play around with it. So I definitely will need to study these functions in Swift. There's some tricky things that they're doing here that may or may not be interesting to me. I'd have to play around with a little bit more. Definitely some things I haven't seen from other languages. Let's see here. Function type. Every function has a specific function type made up of parameters. So we know this one returns back an integer, for example. And so, sure, let's do this. Both of these return back integers, in fact. So let's take both of these functions and let's just throw them in here, and we can run them. There we go. There we go. Now, in the case of, here's another example, a function with no parameters or return value, which again is just kind of like a unit of work that is a dumb unit of work, which in some cases you do want, right? You just want something to just execute a block of logic for you. But this type of function returns back a void, which is interesting. So let's try it. Let's see if I run this and I say, I don't know, I say like result is equal to, and I call that, we can actually go through here and it says, cannot find result in scope. So in this particular example, what we need to do is we'd have to say var results, which I believe should work. And this one says a variable result inferred to have a type of this, which may be unexpected. Add an explicit type annotation to silence this warning. Now, in this particular example, we can say var math function. You can use function types just like any other types in Swift. For example, if you want to define a constant or variable to be of a function type and assign an appropriate function to that variable. And so we could do that. Here we go. And this one is telling us cannot find add two ints in scope because I think I took it out right here. So let's throw these back up here. So yeah, when you do, you do have to watch the variable declaration here when you're getting the results of a function. What else are we going to do here? You can call the assigned function with the name math function. There we go. This returns back 5. We can go ahead and do this. Kind of interesting. And then a different function with the same name can be assigned to the same variable in the same way. And so we can go through and we can do that as well. So there's some pretty interesting things with Swift functions that I think are worth playing around with more than just a cursory level. And in particular, this one is function types as parameter types. Here's an example to print the results of the math function from above. Here we go. We look at this. I define the function. I take the inputs, 2 integers. I return back an integer and also some other values. And then there we go. Let's see, function types as return types. You can also use a function type as the return type of another function. You can do this by writing a complete function type immediately after the return arrow. The next example defines 2 simple functions called step forward and step backwards. The step backwards function returns a value of one or more of its input values. So if we look at this, we can see step forward and step backwards. And we see in this example, it returns back an int. This one returns back an int. So let's take both. I don't see where there's anything fancy going on here, but let's keep going. And then I see, oh, I see. So here's a function called choose step function, who return type is an integer. This choose step function returns the step forward function or the step backwards function based on the Boolean call backwards. So it returns back another function, which is it definitely kind of fun. I like throwing functions around. That's a great way to do work. Let's do that. Let's do this. So if we just run through all of these, we can get rid of it. Yeah, we can go through here. And so what we'd say is you'd say now use the choose step backwards to obtain a function that will step in one direction or the other. Yeah, this definitely is is pretty interesting. I think a little complex to grasp, off the top of my head, why I would want to do this, but definitely looks kind of fun to play around with. And then here we go to anything that takes a function and can return another function is kind of fun. A lot of times you call that functional kerning. Okay, nested functions. No, actually, I guess now we're going to closures here, which is of the functions you've encountered so far, they've been global functions, but you can also do nested functions, which in Python they call closures. And their closures are pretty interesting. And so in this particular example, we have a function that has another couple functions inside. And so you typically, why people do this is to keep track of state inside of a function. So the outer function has inner functions that do state-based things. And so you're essentially keeping a model of the world in one spot. So let's go ahead and try this out. So this is definitely cool that Swift has this. I definitely will play around with this later. And we can see, there we go, it was able to run this. And I guess the next one that I'll cover next week would be closures, which I guess they're kind of setting things up here. So next week we'll cover closures, which are self-contained blocks of functionality that can be passed around in your code. And so this is, I guess, kind of teasing this in this last example, showing that you can nest functions around. And so that would be a natural place for our next lesson, which is closure. So yeah, functions today, definitely some things I need to go back and look at again a few times. There are tons of really cool pieces of functionality, but we were able to tackle it. And then next week, I'm going to cover closures, which is really just functions that have other functions inside that do things, and then you return back the result. So it's kind of like the state of a video game would be a good example for functions. All right, that's all I'm going to cover today. See you next week.